Hi, today I have another video for you on chemical kinetics. Well, chemical kinetics is the study of speed at which a chemical reaction takes place. Till now, we have been dealing with reactions, how a reaction happens, what is the reactant, what is the product, but we haven't had a chance to look at how fast a reaction will take place. And what are the parameters that will increase the rate of reaction or decrease the rate of reaction, right? In some cases, it is useful to slow down the reaction, whereas in other cases, it may be useful to speed up a chemical reaction. And for both cases, we have to study chemical kinetics. We have to see which reactant is going to affect the rate of production of the product and in what manner. Chemical kinetics looks at a reaction mechanism as that will impact the rate of reaction. Reaction mechanism, it is kind of like the process, the steps a reaction goes through to convert from reactant to a product. Okay, so chemical kinetics, again, just recapping, is the study at which the speed of reaction takes place or the rate of reaction. And chemical kinetics is dependent on the mechanism of the reaction. Mechanism, in other words, how or what method or what steps does a reactant go through to convert from reactant into a product. Now, to understand chemical kinetics, we have to look into the collision theory. Okay, so what is this collision theory? Well, to understand how a reaction takes place, we have to look at what is the event that is taking place at the molecular level to convert a reactant into a product. And to understand that event, we have to take help from the collision model. So, for a chemical reaction, the molecules have to collide with one another. Okay, so a chemical reaction cannot happen if the reactant molecules never come into contact. They have to come into contact. The method or the way they can come into contact is by collision. That is the event. All right, and once that collision takes place, some of the bonds have to be broken. So bonds in the reactant, initial reactant, have to be broken, and new bonds have to be formed between the reactant and the product. Sorry, between the two reactants to form the product. Okay, so the bonds in the reactant have to be broken so that it can form new bonds in the reactants to convert from reactant into a product. Okay, all right, so that is the collision model. Collision model is taking into account the event of a collision between the reactant molecules. All right, the two requirements that we have for a collision to be successful. Okay, so two reactants can collide and have no products produced. That is an unsuccessful collision, so it's a non-successful collision there. To be a successful collision, right, there are two requirements to convert a reactant into a product. The first one, when the collision takes place, that event of collision, the collision has to take place with proper orientation. Now, what does that mean, proper orientation? Well, proper orientation has to do with the collision has to happen at the right side or the correct side of the molecule or correct location on the other molecule where it is trying to create a bond. If a molecule collides with the other molecule in the wrong place, that collision will not produce a product. And that is why the proper orientation is significant. When two molecules are interacting or reacting, the collision has to take place at the proper orientation. Right, so that's the first part. Now, proper orientation, again, I can give you an example over here on the right hand side, just a simple example here. So let's say we have a box, a circle, and a triangle. Okay, and let's say our reaction has to take place at the square. So that is where we want our other reactant to come and hit. So they have a circle here, which we want to come and hit. So that's a one reactant and the other reactant. So to make, this is going to be our product. I'm trying to give you a simple example because we're trying to understand the concept here. So that's our product. To make that product, the circle has to come and hit the square. Right? Now, if it comes and hits the square, that is the proper orientation because that's what is going to help us to make that product. On the other hand, if that circle goes and hits the triangle, that is not the right spot, and therefore no reaction will happen because it is not going to produce our product, right? So the circle has to go in and hit the square so that it can produce our product. And that is why that is the proper orientation. That's what we're talking about. The circle going and hitting here instead of going and hitting there. This might result in a product. This will definitely not result in our product. Okay, so this is maybe, so question mark, and this is definitely no. Okay, so circle hitting the triangle, definitely no reaction. Circle hitting the square, a possible reaction. Why possible? Because we haven't satisfied the second condition. Okay, let's look at the second condition here. The second condition has to do with sufficient energy. Okay, so for a chemical reaction to take place, the collision has to happen with sufficient amount of energy. All right, what is the sufficient energy? Enough energy that overcomes the activation energy that is required to convert the reactant into product. Right? So I'll give you an example of activation energy or sufficient energy. If I have a piece of paper, right, we know there is a lot of stored energy in a piece of paper, but the paper is still in the same form as paper. It does not ignite on its own and release all the energy. Why? Well, because there is insufficient activation energy. Is there a way I can provide the paper enough activation energy so that it can release all that stored energy that is stored in the paper? Yes, I can bring a matchstick close to the piece of paper, and that matchstick will give enough energy to the paper to start to combust because it will overcome the activation energy. That burning is again an exothermic process, will release more energy, which will cause the reaction in the next set of particles, next set of particles, and the next set of particles. And over time, the entire piece of paper is going to release all of the stored energy that was in the form of paper, and it's going to convert into carbon dioxide and water vapor. Right? That is the activation energy. The activation energy is the amount of energy required to start a reaction. Right? It is the, if you want to think of it as energy debt a substance has that it has to pay to start the reaction. Okay, so for any chemical reaction to happen, two requirements are required. All right, two things have to happen. The collision has to happen with proper orientation, so in the proper place, and with sufficient amount of energy, which is called the activation energy. I hope you found this lesson useful, and if you liked it, please hit like, subscribe, and look forward to new lessons coming up soon.